Hello everyone and welcome to my YouTube channel again. So today our topic is denial of service policies in FortiGate firewall. So what is denial of service? For example, you are having you are having some servers who in your DMZ zone who are serving a specific service like HTTP, HTTPS or any DHCP server, okay, or for example RDP servers. Okay, so there are possibilities that attackers from the outside world they can generate by using Kali Linux server. They can generate a broadcast of that services on port number. For example, you are having a HTTP server, so that attacker from the outside world they can uh, generate a HTTPS on port number 80. It can generate multiple packets. So what will happen? That server ports will get exhausted. Okay, and that server will not serve the other users who are the genuine clients, and the attacker will be successful. Not only on port number 80, it can happen on any specific server. For example, HTTPS is there. For you are having any RDP server, you are having one telnet server, SSH server, okay, or a server or a specific server who is running all these applications of SSH, telnet, or HTTP and HTTPS. So to protect our DMZ servers from such kind of attacks, there is a feature in FortiGate firewall that is known as IPv4 DOS policy. Okay. So I will show you the basic configuration which I've already done on this FortiGate firewall and on this routers. First of all, so this is our LAN port 10.1.1.1, and this is our DMZ port. We're using the subnet of 20/24, and that's all. And I have taken this interface for management reachability, and I have configured these routers, and I have given static route towards this next hop IP address of the FortiGate firewall. Similarly, on this router as well. So I have created firewall policies as well. So these things are already cleared in my previous videos. So that's why, I don't prefer to show you guys this again and again because I don't like to create long videos. I would like to create short and simple videos. Okay. So this is how it is. You can just see, and this is for LAN to DMZ. And we don't need NAT on both the firewall policies because it's in within our LAN only. Intra it's a intra region communication, not inter region communication. So what I'll do now, I'll show you how we can configure IPv4 DOS policy. So I'll go over here and I will define what I'll do. I want to block the ICMP services. If this router is acting as an attacker and he is generating ICMP traffic towards this router, so I want router to block those. Okay, so I will give it as a name as ICMP. Incoming port will be LAN port. This one, port 3. Source, you can define a specific source. If you want to block a specific source only, like who is going to generate an attack, then you can create an IP address over here. But for our lab environment, I will select all. And destination will be also all. Services will be all. Now, this is the main action. Okay. Here you can define for what kind of protocols you want the traffic detection. Okay, so when the attacker is going to generate the traffic, I simply like protocol flooding traffic. So in that cases, you can define it over here. So you can just log in and you can define the action as block. Okay, how many IP source session uh, the source address the attacker can form. So here it is by default mentioned as 500. So I will make it as 100 over here. We don't want 5,000 connections to be active at a time. I will make 10, and I will make 10 as well over here. But this can behave as a false positive also, because there are some traffics which are genuine and they will require 5,000 connections. Okay, so you have to, in such cases you have to uh, properly design your network, like what kind of traffic is there. Because such kind of things are genuine, they cannot be attacker every time. Okay, now I will go, and this is the main. I will go over here. Now one by one I will, disable what I want. So there are three actions: disable, block, and monitor. Disable, the name itself is it's representing itself. It will not do anything. It will disable. Block means if it is detecting any threshold violation, then it will block that specific service. Okay. And what is monitor? It will just monitor. It will not do anything. It will just give you the logs over here in the log and report. So what I'll do, I will just enable block it for TCP as of now. ICMP flood. Okay. Okay, ICMP source destination, because we have defined the source and destination. This everything will be blocked, and that's all. Now, how many ICMP packets you want? For example, I will mention it over here as for example, say I will give it as 200. Okay, and just click on OK. So what will happen whenever now an attacker will come? When he will try to generate ICMP traffic from outside to the DMZ servers, the attack will be not successful. There will be some packet loss, but because we can see the violation in the anomaly section of the FortiGate firewall. So what I'll do, I'll try to ping this router from this router from LAN to DMZ, because our DOS policy is behaving in that way only. So I'll try to ping. Let me confirm the IP address. What is the IP address over here? It's 21.1.1.2. Okay. I will do normal ping of 5 packets. This will be successful. But what if an attacker is coming, is trying to generate and traffic of, for example, say 5,000? Okay. Or yeah, I'll just make it 5,000. Okay. Unfortunately, it is successful. It should stop. But not sure why it is not giving us an packet loss. We check over here. It will give us packet loss over here. Okay. Just log the sweep enable. Okay. And I'll click on OK now. Let me check it again. See, entire traffic is successful. It should not happen. I'll show you. Let me reduce this threshold to, for example, say 50. I think now it should give us packet loss. For example, I say I'm generating a, see, it has started giving us some packet loss. Because the threshold was higher, I think that's why it was not detecting it. Although the ping is not getting continuously stopped. Okay. But we can see the attack is also not that the attack rate is getting reduced. Here it was 100% successful, but now you can see the success rate will not be 100%. If you want to check it, you can go into log and report and go into the anomaly section. Okay, now you guys can see count is 11. You can see 10.1.1.3, which is our router. This router, okay, this one is trying to generate an attack. So that attack is known as ICMP flood attack. If you click it over here, you will see this indicates that the rate of ICMP packet to an IP address is above the specific threshold level. Okay, this indicates possible ICMP flood that is usually accomplished by broadcasting a large mass of ICMP echo packets. During the attack, I spoofed IP packets containing ICMP echo request with a source address equal to that of the target system and the broadcast destinations are sent to immediate network. Sending an ICMP request to a broadcast target address, all hosts included in the network respond to a ICMP reply packet, thus creating a large mass of packets which are routed to the spoofed address of the target. The target system is then slowed down or even crashed by the flooding packets. So this is where the attack happens. Okay, the target system is then slowed down or even crashed by the flooding packets. The flooding packets are being generated by the attacker towards the servers, or it can be any endpoint. You guys can see now the success rate is 98%. Although it's not successful, let me try for 100. 100 it is also not successful now. It's 99%. Now I will generate some more traffic for 5000. Not more traffic. What I'll do, I'll increase the size of the packets. What I'll do, I will make it as 1800 above the MTU. So there are lots of things in this, like this DOS profile packet. Okay, it's not that simple. You can create it for other policies as well, like for example, if someone is trying to generate any UDP flooding traffic. Now what happens in case of ICMP? Okay, I'll just explain you. This is another topic. ICMP doesn't use TCP or UDP, okay, while it's generating the packet. That's why I've disabled this everything, because none of them are going to get used while generating the packets. Only ICMP, on its own it's working. So our the proprietary things are there, like for example, TCP is there, UDP is there, SCTP is there. You can define them, and you can define the threshold what you want, so that the attack will be get reduced. Also, the rate is 98%, which is not that the success rate is not that high, but it can if you properly plan it, okay, in your network environment, what will be the threshold, the amount of packets that endpoint servers will receive, then you can properly and in a very safe way protect your DMZ servers. So that was the motive of this video. So I wanted to tell you why this thing is needed in network. Thank you for watching my videos. Stay tuned for the upcoming videos.